Hi, well it's Evan Lewis again, and this is Evan Escent channel, and since we have a nice sunset tonight I thought we'd just take a little background. It's a genuine background. Then we'll start talking about how to use RideTheGearTrain. And I've decided I need to talk more slowly, and I'll try and slow myself down, but also I decided to split the instructions into a couple of parts so that we don't have to squeeze too much into one video. So this part I'm going to be talking about mini-lathes, and then we'll go on from here into part 2, which will be more general information about how you use the program once you've specified your lathe. So here goes. So before we go into the program, let's talk a little bit about what it does. This is a program for working out the gear train that you may want to use on your lathe to cut a thread. And the way this works is that it goes through all the possible combinations of gears that you have. So you enter your own list of gears, so it's specific for your particular lathe setup. And if you have a gearbox, we specify that as well. And it goes through every possible combination of gears and gearbox settings that you can do, and calculates the pitch of the thread that will be produced in each case and compares it with the pitch of the thread that you requested. It may match perfectly, in which case we say there's 0% error, but it may be just a close match, and that can be just as useful and provides a lot more possible solutions to the problem. So one of the things we have to enter is the amount of error that we're willing to accept, and I usually suggest starting off with a fairly high percentage like 2%, and then later on narrowing down to say 0.5% or even 0% if you're getting a lot of results. So whenever it finds a thread which is in the error range which you have selected, in other words it's accurate enough for you, then it keeps that result, and once it's gone through all the different possibilities, it produces a display with a list of all the possible gear trains you could use to make that thread. And then beside each solution to the problem, it has a button called Draw, and if you click the Draw button, it actually draws a scale diagram of what the gear train will look like. So that's a quick overview of what you expect from the program. Now the thing we're going to be talking about first is how to go about setting up the brand of lathe you have, and that includes how to enter your gears, and we'll go later to seeing how it runs. Well, when you first start the program, this is what you'll see. And actually, let's look at the address bar on my browser here, and you'll see what I typed in to get to this point. It's herosteamengine.com/RideTheGearTrain, and you don't actually have to put the index on here. Just RideTheGearTrain will do it, and you can actually find it on Google quite easily too. Just type in RideTheGearTrain. So that gets us to this point here. We don't need to worry about much of what's on here, but we've got Contact Us, so if you ever need to contact me about anything, I'm right there. We've got a quick introduction here which includes a quick start guide, but let's scroll right on down to the menu itself. And this is the main center point for the program. We keep coming back to this point, and there's a series of steps you go through to enter the data first, and finally you get to step 6 down here and run the program. So the first thing you enter is the type of lathe you have, and we'll go through that, and then you enter the gears that go with that lathe. And that's all we're going to do in this tutorial, and then we'll have a second part where you go on and enter the type of calculation you want, whether you want a thread with millimeters pitch or threads per inch or calculated feed rate or something like that. So there's actually 8 different options on that list. Then we come to enter the acceptable error. That's what we were just talking about, or the error that you're willing to accept. The next 3 steps, you only choose one of these 3, and it's actually really one step, step 5. And the first one is very straightforward. You just put in the pitch of the thread you want, and then you go straight to run. An alternative is to request a range of threads and click run, and the third one is to look up a reference table to find out what pitch your thread has, and then go to run. So that's how the thing is basically structured. We're going to be talking about mini-lathes, and they require some entries on this list here, and perhaps I should go to that during this episode to explain what special entries are required for the mini-lathe. So we'll start with the entering the lathe model in step 1. Choose a lathe, and we've just got a long string. There's actually about 20 different lathes on here. But if you've got a lathe that has no gearbox, you might want to choose either an imperial or metric one with no gearbox, and we should be able to do any lathe of those types with no gearbox. But we're going to be talking specifically about mini lathes, and this is a particular mini lathe which does not have a gearbox. It's a Walco brand, a UK importer of a Chinese lathe, and so we'll just select that. And if we want to know more information about any step we go through, we can go to the help file over here on the left. So each entry has its own help paragraph in the help file, and we can go straight to it with this. This one actually has two different topics we can go to. And actually it says down here what the yellow one is for. It's to learn about the peculiar labeling systems that these lathes have on their gear trains. And then the other green one is the standard help file about that particular brand of lathe. So let's just click that just to show you how the help works. Clicking it, nothing happens except a little red box appears. We also have to press return to menu or help, and that actually takes you to the help screen. When you get there, it's asking you to click again to go to the particular section you requested. So we had apparently requested to learn more about Walco mini lathes, metric version. And the reason we have these 3 steps to go through is because when you go back to your program, it takes you back to the same point where you were entering data, and the data you enter is still there. So you haven't lost anything by going to the help file, and that's why we have to go through these 3 steps. So click that, and here we go, a paragraph about this particular type of lathe. And I stress it is actually fairly important to look at this, I think, because of this lathe being somewhat different to other lathes. There's another mini lathe on here which we'll come to later, is the Precision Matthews Chinese imperial mini lathe, and this one has a gearbox, and it also uses the peculiar Z labeling on the gear train. So we'll probably come back to that one later, but in the meantime we've just read about feed rates and everything on the Walco lathe, and when we're finished we click return to program, and you'll see we're back exactly where we left off, so we haven't lost anything, and it's even selected our Chinese mini lathe with no gearbox. Okay, once we've selected that, we can return to the menu again, and see you don't have to scroll all the way to the bottom. We've got a return button on every line, and we're ready to enter some gears. It wants to know how many compound gears we're going to use. Now this particular type of lathe, you can't vary the stud gear, which is the one that most conventional lathes, you have a stud gear at the top which you can change, and we'll talk about that some more later. But because this particular type of lathe doesn't have a changeable stud gear, and this one doesn't even have a gearbox either, we need to get quite a wide range of different gears from the gear train. And if we chose no compound gears, it really wouldn't give us enough selection. We need at least one compound gear in the train, and actually the standard gear trains that are shown on the tables for these lathes often just use one compound pair. I think I'll do that first because it's less complicated, but you can actually choose 2 compound gears, which gives you an even wider range of possible solutions. Or let's look at all 3 of these diagrams showing the gear trains. This little cluster of 4 gears at the top, they don't actually affect the gear train ratio at all. They're just there to allow you to go into forward and reverse on these British type lathes. But the Chinese lathe doesn't have all that. It only has this one gear here, the blue one, and whereas that gear can be changed on British lathes, the Chinese lathe you can't change it. The simplest setup is to have an idler gear, which then just drives the lead screw gear. Now the idler gear, you'll need to remember, does nothing in terms of the gear train gear ratio. The only thing it does, it reverses direction of rotation, and these lathes always have some kind of reversing mechanism on them anyway, so you can switch it over. So as I say, this doesn't affect the gear train ratio, so it's just like having a 20-tooth gear driving a 56-tooth gear. And if you can't change that 20-tooth gear, that only leaves the lead screw gear that you can change, and it doesn't give you a very wide range of selection. So it's more usual to go to a system where you have at least one compound gear in the middle, and that'll give you most of the solutions you want. So in this diagram we have two gears that are joined together on a key, so they turn around together. Sometimes they're actually riveted together, but not on the Chinese lathes, because on the Chinese lathes you can use any of the gears you're provided, put them together in any way you like, and mix and match. I call it mixing and matching, where you use any gear in any position along the gear train. You're not restricted like you are on some of the British lathes. So in this case we have the stud gear, which again cannot be changed. It's set on 20 teeth in this case, and it's driving, at this point here, is driving the 127 tooth compound gear, which is physically connected to another gear which has 100 teeth, and the 100 tooth gear is connected here to the lead screw and causing it to turn around. So we have now 1, 2, 3 gears that can be changed to produce a wide range of threads. And so that's what we're specifying here when we click one of these buttons, 1 or 2 compound gears. This is the version with 2 compound gears. Same kind of setup, except that you've got one pair of gears here driving another pair of gears, which then drives an idler, which does nothing, and then through to the lead screw gear. So it looks quite complicated, but on the Chinese lathes you don't have this cluster of 4 gears at the top, and you just have these 2 compound gears connected together as pairs, and they have keys that connect them together, so they turn together. So this pair turns together, and that pair's another set, and it turns on its own shaft. And this gear is just in here to make it easier to connect this gear to that gear, so otherwise it wouldn't be necessary. So that's 2 compound gears, and we decided we'd choose 1 compound gear. Let's make sure I did that. 1 compound gear, checked. It's green. Green means it's selected. Little dot in the middle for those who are colorblind. As I was saying, in Chinese lathes you can use any gear in any position, so they can be mixed together in any way you like. And if you choose automatic compound, which is normally what we do, it automatically goes through and works out all the different ways you can put those gears together. It's only the certain British lathes and American lathes that can't do that, and you have to use a manual system. Finally, you can enter your own list of gears. And because the mini-lathes don't have a very good gearbox, they tend to give you quite a long list of gears. And these can be put together in any way along the gear train. Have a look at this list and check that it's the same as what you've got. It may not be. And edit this list. You can say, oh, I don't have a 24 tooth gear, so you can just take it out. And so that's gone from the list, and it won't try to use 24. If you've got a completely different list, you can just erase the whole lot and type in your own list, or you can delete that and just get one of the standard lists from here, copy and paste. And since you can do that, you can also set up your own file if you want to. Just keep a record of your list of gears. You can put that in a text file and just bring it in whenever you want. However, that's not really necessary, because this list is actually recorded in the URL for the program. So actually all of the data that we enter here is stored in the URL. It has 100 variables in there, and if you save the web address, the URL, it'll save all your data as well. So if you use that as a favorite or bookmark and click on it next time and come back to the program, you'll find that all your data is there again, because you used this particular personal URL. Then there's a list of compound gears, but because we're using automatic mode to make up our compound gears, we don't need to use that. So with the Chinese mini-lathes, you do not use a separate list of compound gears, and it's just left empty here. And if there's anything written in there, it doesn't matter, it won't get used. So we've done that. We can now return to the menu, and there's another item that we need to look at in specific reference to the Chinese lathe, and that is optional entries. Now this is already set up for you. If you chose a mini-lathe to begin with, this will have been inserted into the data within the program. So everything should be okay here. The first item just specifies how many results you're prepared to look at. Do you want to look at the 2,000 different options? You could actually reduce that if you wish. The program will stop after that limit. Some lathes have power feed on the carriage and others have it on the cross slide as well. If you're using the lead screw to drive the carriage along, then there's no special gear ratio in here, and this just is set to 1. But some lathes do have a gear in the carriage which slows down its movement when you're using power feed, so that you get a nice fine cut. So most more sophisticated lathes do have a gear in there, and often this ratio, instead of being 1, will be 0.3. I've assumed that the basic mini lathe doesn't have that feature and simply uses the lead screw to drive the carriage along, and in that case the ratio is just 1. The other ratio here, if you can look at the icon here, it's got an arrow going across the cross slide, so that's for power feed going across the lathe on the cross slide, and it's also set to 1, but it could be a different ratio. Now this is something about the Chinese mini lathes. This shows the stud gear that cannot be changed. So that, remember, the previous diagram we looked at had a cluster of 4 gears in here. They are no longer present because we're looking at the Chinese lathe, which has this just 1 gear. The problem is that this gear is actually machined into the end of the spindle shaft. On the other end of the spindle shaft we have the chuck. On this end at the back of in the gear train, the shaft comes through here and it's got these teeth machined onto it, so that's why they can't be changed. So that can drive a single gear, as we looked at previously, which drives the lead screw. So we just have to tell the computer program that that gear cannot be changed. It is shown in red here for that reason, and we have answered no here. No, it cannot be changed. You can go back and change these settings, but that's appropriate for your Chinese mini lathe. Now we have to actually tell it, well, how many teeth does that gear have? We're not going to change it, so let's put in now that it has 40 teeth. I have seen others that have maybe 55 teeth, especially if they have a very large hole through the center of the spindle. There are some lathes, and not necessarily Chinese ones, where the lead screw can't be changed, the lead screw gear. On the other end of the gear is either the lead screw itself or the lead screw gearbox. And because it's incorporated in the gearbox, sometimes it cannot be changed. However, on the Chinese mini lathes, they generally can be changed. So I said yes, it can be changed here. So although we've got a box here with a number in it, it doesn't need to use that because we can vary it. This is something you might need to know about, because the Chinese mini lathes usually will have a 1.5 millimeter pitch on the lead screw, and some have 2 millimeters pitch. And if you're using an imperial lathe, it'll be different again. It may be 16 threads per inch. So this should be set up for your particular lathe, but if your lathe is different, and especially if you seem to be getting some strange results, you may need to come to this section called optional entries and check that the pitch of the lead screw has been set correctly for your lathe. Beyond that, there are some advanced modifications which you won't need to get into. This is used by people who have some peculiar lathe which is not mentioned on our menu, and they want to get an existing lathe and do some minor modifications to it, but I don't think we need to get into that. We haven't looked at a Chinese lathe with a gearbox, so let's go and have a look at our lathe selection again. And last time we chose this one, the Chinese mini lathe with no gearbox, made by Walco. Below that, in the gearbox section, we have another Chinese lathe. This one here, mini lathe by Precision Matthews. That's the lathe used by Quinn Dunkey in her BlondiHacks series, and if you haven't seen her videos, it's well worth watching them. And she kindly gave me permission to take some snapshots from her videos to show here. So we'll select that, and perhaps we'll also have a quick look at the help file there. And there's quite a lot to read. Here are the links to her videos. This is about buying an imported lathe. Very good production. program, and another one that's excellent to watch is how to cut a thread on a lathe. So if you haven't had any experience doing that, it would be well worth watching. I also have my own video about cutting threads as well. My lathe has a variable speed motor, which I think a lot of Chinese mini lathes have too, and that's very handy for slowing down as you approach the end of the thread. The main reason that I stress the importance of reading through these instructions is that the labeling system for these lathes is rather peculiar, and I think this is the system that's used on most of these imported lathes. They label the gears Z1, Z2, Z3, Z4 and L, and at first glance it looks fine, but it turns out that they don't label them in the order that power is transmitted through the gear train, and so there's no correlation with gear ratios with this numbering system. They're actually labeled according to the way you put them on the little stud shafts, and these can vary in their order of rotation. So I think it's best just to skip and forget about this labeling system when you're using my computer program. When you're using the program, it labels the gears as compound gear 1 and compound gear 2, and this pair is 3 and 4, and this is the lead screw gear. And as we said previously, this gear is fixed and cannot be changed, but is usually 40. So I talk here quite a lot about this complicated labeling systems that are used, but I would recommend actually just forgetting about all that and just using the labeling system that I use in the program, because we're not going to be using the specific tables that they use on the front of the lathe. If you do need to study the way they've done it, I've drawn this little diagram here. This is actually for doing feed rates, but it's the same thing for cutting threads really. They don't actually show the stud gear or the spindle gear. Actually, I should call it a spindle gear on these lathes because it's on the end of the spindle or shaft. So that shaft that goes through from the chuck is called the spindle, and it has a gear on the end, so it should probably be called the spindle gear. But it's the same thing as a stud gear. So this 40-tooth stud gear drives a 63-tooth gear here, and it's a compound gear. The blue line indicates that it's connected with a keyway to another gear, so 63 and 30 are connected together. That would be this pair. And then a 30 drives an 80-tooth gear, which is also a compound gear, with 80 driving 40, and that's the second compound gear. And then that gear drives the lead screw gear with 75 teeth, and that's the lead screw gear. So that's how their system works, but we'll just call these compound 1, 2 and 3, 4 in the order that the power actually transmits through the gear train. When we're finished, we can click the return to program button, and we'll do something a little different with this lathe. We're going to use 2 compound gears. So I'll go back to the main menu and go to the gear selection section, and that's where we choose whether you have no compound gears, 1 compound gear, or 2 compound gears. It's already selected actually. Then we'd be ready to run, and we'll do that in the next section. Okay, so I think we're finished this part of the process of going through basically steps 1 and steps 2. The rest of the steps are the same for everybody, so I'll make a separate instructional video for that part. Thanks for watching.